Okay, so in this next video, we're talking about the quotient rule. Okay, and with the quotient rule, if you recall, when we had the same base and we were dividing, for instance, maybe add 4 to the third over, third, raised to the 4 to the second, when they had the same base, we could subtract the exponent. So 3 minus 2 would give us 1, and we'd add 4 to the first, okay? And then 4 to the first would just be 4. Okay, so with the quotient rule, we subtract the exponents. Okay, now the only thing that we might run into is what happens when we have a negative. Well, again, like we've seen in the previous videos, we just have to flip that guy. Okay, and again, with the coefficients aren't the ones that are the bases. They're not the ones being raised to the exponent. For instance, on number 1, 4 over 3. Those guys are just the coefficients, and we can treat it like a fraction. So for instance, 4 over 3, we can treat that as a fraction. Is 4 divided by 3 an even number, or does it divide out evenly? No, okay? So if it doesn't reduce and it can't simplify, we can just leave it as 4 over 3. And then what we're going to take care of is to see, is b going to remain in the numerator, or if it's negative, possibly it could flip to the denominator. Okay, so looking at the base of b, let's just put it at the top for now. We'd have 3 minus 3. 3 minus 3. Okay, well, writing that out, we have 4 over 3. B raised to the 3 minus 3 would be b to the 0. Well, what's anything to the 0 power? 1. So this is really 4 times 1 over 3, which would be 4 over 3. Okay, now there's an easier way to kind of look at it too. Anything divided by itself is just going to cancel out when we get 4 over 3. But just showing you the process, this is what we're going to be looking at. Then, of course, if we have a negative exponent, we're going to flip it so that it's in the bottom in the denominator. Let's try number 2. So looking at that guy, even though we don't see it, we could treat this like it has a coefficient of 1. So the coefficient's 1 over 4. Does that reduce? No, so we can just leave it as 1 over 4. And then we have n to the 4th and n squared. So the base is n, and we're going to subtract 4 minus 2. Well, what's 4 minus 2? 2. So this would be 1 times our n here. We don't have to put times, but it'd be 1 times our n squared over 4. Okay? So we have 1/4 n squared. Okay, now since the exponent is positive, we really don't need to do anything there. And in fact, since it is 1 times n squared, we could just say it's n squared over 4. Okay, but either way, it's 1/4 n squared, or we could say n squared over 4. Okay, number 3. Again, even though we don't see it, we could treat this like a coefficient of 1 for now. So we'd have 1 over 2. That doesn't reduce, so we have 1/2. Then our base is n. And even though we don't see it, this has an exponent of 1. So we have 1 minus 0. Well, what's 1 minus 0? 1. So we have 1 times our n to the first power over 2. Now, technically, this is okay. We could simplify it a little bit further. Again, we don't have to put 1 here because 1 times n to the first is just n to the first. And then what's anything to the first power? Just itself, right? So we could say this is n over 2, okay? N to the first is n, and then n times 1 is n. Okay, number 4, 3 over 2 doesn't reduce, so we're going to keep that the same, 3 over 2. And then we have r with the 3 minus a negative. That's important. Don't forget the negative. Minus a negative 1. Well, what happens when you minus a negative? It changes to a plus. So we'd have 3 over 2 and then r to the 4th. Okay, no changes need to be made here. We have a positive exponent. Moving on to number 5. Okay, now number 5, again, if you see the same thing on top and bottom, it'd be just quick and easy just to cancel it out. But just so that you understand, 4 can go into itself once, and then we'd end up with 1s, and then we don't have to write the 1 times the x to the 4th and then 1 times x to the negative 2nd. But an easy way to think of it is there's a 4 on top and bottom. They're just going to cancel each other out. 4 divided by 4 is 1. Okay, so those guys are just going to go away. And what we're left with here is our base of x to the 4 minus 2. Now I'm going to write it somewhat as a fraction for right now, and you can even put 1 here because like we talked about, if it helps you to see that this is a fraction, we could put 1 here for now. But I'm going to write this, and then we'll decide if we need to flip it or not, or if we can just keep it as a numerator and what it should be simplified as. So 4 minus a negative 2, 4 minus a negative 2, don't forget the negative like I just did. So when we subtract a negative, we have a plus. So 4 plus 2 would give us 6. Okay, then anything over 1, we don't have to actually write the 1 because anything over 1 is just going to be itself. So we have x to the 6th power. Okay, number 6, again, even though we don't see it, for right now we could treat this like it has a coefficient of 1, and we have 2 over 1. Okay, 2 over 1. And then we have n as our base, and we have 2 minus 3. Okay, so let's see what we get with 2 minus 3. Let's keep the coefficients for now. And 2 minus 3 would give us negative 1 over 1. Okay, well now this is like the product rule when we looked at it in the last video. What's the only thing that's going to flip? Is it the 2 or the n? The n, because it has the negative. So 2 is going to stay on top, but the n to the negative first is going to flip to the bottom, and we'd have n to the first. Okay, so that guy's just going to flip down, and 2 would remain on top. Now again, do you have to put n to the first power? No, we could just say n, okay, because anything to the first power is just going to be that thing. So we'd have 2 over n, okay? And then number 7, okay, just for now, we can treat this like that as a coefficient of 1. So 1/3, that doesn't simplify. Then next guy that I see is x. This would be a good example of things canceling out. You have x on top, x on bottom. Let's not even worry about x. And then we're just left with times y squared. Okay, so we have 1 times y squared. There's nothing to do here. We can just leave it as y squared over 3. Okay, 1/3 y squared isn't wrong. It's just since we have 1 times y squared, we could just say 1 times that is y squared. Okay, then 8, again, we have 2/3. Okay, 2/3. We have a base that's x squared, but there's nothing to do with it, so I'm just going to leave it there for now. Then the next base I see is y, and we actually have something we can do with it. It's a negative 2 minus a negative 4. Okay, so we didn't have anything to take away here with our x, but we do have something with the y here. So let's simplify this. We have 2x squared, y raised to the, when we subtract a negative, it changes to plus. Negative 2 plus 4 is going to give us 2 over 3. Well, do we have any negative exponents? No, so that's as simple as we can go. There's nothing to change here. If we have positive exponents, we're okay. Okay. Number 9. Again, this is a good example where we can just kind of cancel things out if we have the same thing top and bottom. And notice we actually have the same thing top and bottom here too. So save yourself a headache. They just go away. And what we're left with, you could treat this like it's a 1. What we're left with is b to the negative 3rd over 1, right? Okay. When we're canceling things out here, keep in mind it's really like 1 and 1, but just so that we understand that there's really a 1 at the bottom, that's why I'm writing it here. And then that also helps us because it's b to the negative 3rd power. What happens with the negative? It flips down, okay, so that it becomes positive. Okay. Number 10. Looks like we have 4/3. That's not going to reduce. So 4/3. We have a base of a, and we have 2 minus a negative 3. Okay, minus a negative, we're going to change that to a plus. And then we have a b with a negative 2 minus 0. Okay, so looks like we're going to keep our 4/3. 2 plus 3 is going to give us a 5. And then negative 2 minus 0 would give us a negative 2. Okay, well now we have a negative exponent. So again, anything that's positive, we don't have to do anything with it. The only thing that's going to flip is the negative. So keep everything else the same, 4 times a to the 5th, but now the b to the negative 2nd is going to flip down so that it's in the bottom. Okay, it's just going to go down here. Okay, and then lastly, we have number 11 and number 12. Number 11, again, let's save ourselves a headache. We could get rid of these 4s. Well, actually, I mean, we could, but actually, let's back up real quick. Since they have the product rule, notice they have the product rule on top. Let's combine those together first, and then we'll come back to this, okay? So in this example, they actually have the product rule on top, and then we have the quotient rule all together, okay? So let's take care of the product rule first. 4 times 2 is 8. A squared is going to stay the same. B squared has nothing to go with, so it'll stay the same. But can I combine these c's together? Yeah, by the product rule, what do you do with the exponents? You add them. So even though we don't see it, there's a 1 here. So 4 plus 1 would give us c to the 5th. Then in the bottom, we'd have everything the same. Okay, so this is just an interesting case where they actually had the product rule first. But now we can apply the quotient rule. 8 over 4, I can simplify that. This reduces to a 1, and this reduces to a 2, because 4 goes into itself once, and 4 goes into 8 twice. Now, with that in mind, we can leave that as our coefficients for now, and then if we need to change the 1 or we can get rid of it later, we can. Does A have anything to subtract here in terms of exponents? Do we have another base of A? No. So that guy's going to stay the same. What about B? Well, yeah, we have a 2 minus 0, right? 2 minus 0. And then C, we actually have that guy too. We have a 5 minus a negative 2, okay? So if that's the case, okay, we have 2a squared, 2 minus 0 would be 2, and then 5 minus a negative, 5 plus 2 would be 7, okay? So you could say it's over 1, but do we really need to put it over 1 since there's nothing there? Not really, okay? So we can go back here and just leave it as this since we have division by 1, and that would be our solution, okay? Last one here. Again, this one's kind of unique. It has a product rule on top, so let's take care of the product rule, and then we'll take care of the quotient rule. So even though we don't see it, we could treat this like it has a coefficient of 1. 1 times 3 would be 3. And then to go things in alphabetical order, let's do A first. So we have A, and we have a negative 1 plus 0 would be a negative 1. We have 1B, nothing to combine it with, so it's still B to the 4th. And then we have C, and it looks like we have C to the 1st power plus a negative 2. Well, 1 minus 2 is going to give us negative 1. And then we can keep the bottom for now and see what we're going to keep and what we're going to get rid of. And I'm actually going to move the A over here. It really doesn't matter where you put it, but I'm going to put the A over here just so that we can see where what things we're going to subtract, okay? So looking at this guy, notice these 3's, I can get rid of them. I don't need those. So what I'm left with now, whoops, that's not what I wanted, okay? What I'm left with now is I have A, and I'm going to put everything over 1 for now. Okay, notice we've always been putting everything on top, right, at the beginning. Well, I'm going to put everything on top for now, just like we've been doing, and we'll put it over 1, and then we'll see if we need to flip anything, if anything's negative, okay? So for now, let's just put it over 1, and we have A to the negative 1 minus 2, okay? Then there's B, because that's being multiplied to B to the 4 minus a 1, even though we don't see it. And then C to the negative 1 minus 3, okay? So then subtracting our exponents here, we have a negative 1 minus 2 is a negative 3. We have 4 minus 1 is 3. And then we have negative 1 minus 3 is a negative 4, okay? Well, now I'm happy that we have it over 1 because the ones that are negative are going to do what? Flip. So the A is going to move down, the C is going to move down, and B is going to remain on top. So we'd have B cubed on top, it's positive. The negative goes down, and the negative goes down, okay? Now, you could keep the 1 here if you really wanted to and say it's 1 times all this, but you don't have to, okay? Because 1 times all that is still going to be that, okay? So this would be our solution, all right?